So in this video we'll discuss about architectural design. So let us discuss why architecture is needed. So architecture is it's not a software application software, it's just a design. So the architecture helps to analyze the effectiveness of the design. So why we need the architecture? So the system design will be described in that. Then if there are many alternatives are there, that also can be designed and it can be compared one with another. So the architecture will help in those cases, and it will help us to minimize the risk which will appear later. So instead of that, in the design stage itself, we can identify is there any flaws in the design or not. So why architecture is needed? What is the importance of that? We'll see. So it will represent how the software is going to be. So that can be viewed in the architecture. And what are the various designs available, and whatever the decisions we have to make here, that can be made in the architecture phase itself when we design the software. So there are many architecture descriptions. IEEE Computer Society, they have given some of the description, and they will mention what are the different design softwares available for designing any application software or system software, and what are the various guidelines which has to be followed for designing the software. So these are the things mentioned by IEEE Computer Society. And the IEEE standard also, they have described about the architecture in their own terms. So there are different collection of products which are existing for the architectural documentation. So there are different architecture journals are available. So under if you consider software domain, there are various categories are available, and within each and every category there are subcategories available. For example, if we consider the buildings, there are so many sub-genres available, like houses, apartments, and industrial buildings, etc. So for each and every software architecture genre, we have to follow a style. The style consists of structure and predictable patterns. The architecture style consists of components, connectors, constraints, and semantic models. So if you consider the components, which are all the different functionalities available, for each and every function, different modules are designed, and how the modules are interconnected to one another, that is designed by using the connectors. So how the connectors are going to interconnect the different modules, for that what are the different conditions available, they all will form the constraints. So how the modules are defined, how the functionalities of each and every modules are defined, what are the data they are going to work with. So the complete model, if you consider, that will form the semantic model. So next we are going to discuss about different architectural designs. They are data center architectures, data flow architectures, call and return architectures, object-oriented architectures, and layered architectures. The data center architecture is shown in this figure. So it consists of the data storage device. So there all the data will be stored in the backend. So all the client softwares, the application softwares, they will be accessing the data storage, accessing the device, accessing the data, or inserting the data, or modifying the data, retrieving the data. All those operations can be done through the client software, but the data storage is at the backend. So this is the data centered architecture. The next one is data flow architecture. So here the data will be processed in various stages, and they are like a pipeline architecture. So all these pipes can work parallelly. So here the filters will be expecting the input in a specific format and produce output in a specific format. So all these pipes they can work parallelly. Next one is call and return architecture. So here the modules can make use of the subroutine calls. So the main program can call the subprograms. The subprograms in turn call the other subprograms. So here, after executing the subprograms or the subroutines or functions, the processed intermediate results can be written back to the called function. So this is the architecture of call and return architecture. The next one is layered architecture. The components of layered architecture is user interface layer, application layer, utility layer, and core layer. So in the core layer, the database and data warehouse or data storage facility will be available. So here it is hidden. It is in the abstract level. So it is hidden from the end users. So the utility layers will be accessing the system functionalities and the system devices. So the application will not access the system devices directly. So here the application layer, it is designed to work with the data storage facility through the utility layer. And the user interface layer, it will not access directly the data which is stored in the core layer. So it will be accessing through the application layer. So here one layer functionality is hidden from other layer functionality. So thank you.